right. This is how things are going today. That's my session talk topic title. So we're going to go into this. So a couple of housekeeping. I really appreciate more collaborative presentations as we talk through some of this stuff. We're going to need to be a little bit more collaborative because I may be missing a few slides that I didn't have time to recreate, but that's okay because we'll get through this and I have a lot of really good ones otherwise. But today we're going to talk about the barn stack. Does anybody use the term stack in their kind of daily? And do you use it from a platform perspective or from like an app dev perspective? What does stack mean to you? Yeah, platform stack, awesome. So it's becoming a more popular thing. Who else? Yeah, same. Awesome, that's actually great. Normally, we think of stack as like lamp stack, right? It's something that was really coined from the app dev side, like a collection of tools and parts that work together. So this agenda is loosely what we're going to touch on, but it's mostly in order. We're going to touch a little bit about platform concepts and what that means. That's basically I get to monologue and shill for the platforms working group with the CNCF. I need to move this one down, I suppose. We'll talk about, at some point, the software platform demarcation line and how that's kind of shifting and evolving and moving and how we handle that. And I will briefly talk about the concept of a software factory. Has anyone used the term software factory before? So VMware has talked about some of that, but I guess they're kind of the only case. What about blueprints? Cool. And does anybody, do you think stack is the same thing as a blueprint? Or, yeah, I don't either. Cool. Perfect. So we can go through some of that. Then we'll talk about really the barn stack and what that means and where we're going with that. So I guess I should probably use the slideshow. Is anyone familiar with the CNCF Platforms Working Group and the platform maturity model and the white paper, and there's an upcoming platform as product? Cool. So I'm a co-chair of the CNCF Platforms Working Group, and we do our best to try to facilitate all these conversations and facilitate the development of these industry standard artifacts that we can use. A lot of the overlap that I do as well is with the cloud native maturity model folks, cartographos, where we're trying to map business value back to the organization by leveraging things like platform implementation, right? And should you even implement a platform? So this diagram is from the platform's white paper, where the key components of this are in the top. We are trying to infer and map product and applications teams as consumers of the platform. They use the next box, which is platform interfaces, so documentation, graphical user interfaces, CLIs, APIs. These are the things that they do to get their jobs done and create business value. Capabilities underneath are things that those applications or people may leverage to make their applications run or even have things like underlying storage, right? It's really the things that make their apps tick. There are capabilities we're providing to them for them to be able to do their jobs. And infrastructure providers or platform engineers or now DevOps folks or whoever who's creating and providing these capabilities, they're on the bottom, right? They're managing these tools, making them available, and really the core concept of a platform is providing a collection of self-service capabilities to those teams up at the top. Now, one note I'd like to make there that isn't totally clear in some cases, but it is an active discussion, and it's a great reason why we use Rancher and a lot of the SUSE tools, is many times our providers themselves are also actually users of the platforms. And so when we map things out like that, we like to consciously put ops teams or other folks in the consumer side of the platform as well and highlight tools that they may use, like Grafana for observability, right? Or now we use Stack State a lot. And so that's like a really surprising acquisition today, but really awesome. Happy for those guys. But there are interfaces that we'll provide to ops teams as well. So the reality, though, is we're talking about having a lot of conversations. Platform engineering is this big hype word, but there's no one-size-fits-all platform. Every organization may actually have multiple platforms. They're going to start with one, right, and build some practice on top of that. But there's nothing wrong with having multiple physical platforms themselves. It's the approach that really matters, this platform as product approach. It's understanding the needs of your end users, how they function, and how you design and build based on that. Somebody, I don't know who it is, and I'll give you $50 if somebody can tell me who it was so I can go thank them. I really like the phrase that platforms are like a toothbrush. Everybody needs one and wants one, but nobody wants to use anyone else's. Is very, very much true to platform engineering today. So the reality is teams are diverse, teams need flexibility, collaboration. The platform will mold, shift, and change, and there's no end-all, be-all, greatest platform out there. And same thing when we talk about stacks on the app dev side, there's no greatest end-all, be-all stack on the app dev side as well. All right. So this is another diagram that I really, really like. It's by Julio Rogero. He's with Mia Platform. He's shared a lot of these types of diagrams. They do a really great job of communicating the end users' participation in the platform. This does kind of demonstrate, though, too, how complicated this looks. And the reason I wanted to introduce this concept is it's starting to feel like platform of platforms. And platforms of platforms is a diverse topic that has a lot of conversation and argument today. But you'll see in this case, and when I talk about no one size fits all, and the operators themselves maybe even being users of the platform, what we're looking at is potentially one overall organizational platform, right? But underneath the hood, in the eyes of the user and their perspective, we may have a DevOps platform that has a focused team and a group, right? And it's providing a specific set of capabilities to others. We might have a data platform where we're going to have data users, right? And we have different storage capabilities that they may require versus others. Or maybe they need to share with the application access layer or for the application developers and the CI/CD, maybe they need a common storage plane that they need to share. But it's up to the providers, the platform maintainers, to recognize that, see the value, create those connections, and provide that as a capability back to those teams so that they don't have to think about it. But really like this diagram and how you can see the software engineers on one side and platform engineers on another and data teams and all that. So really good job from them. Let's see. All right. So I wanted to look and touch on kind of the platform evolution a little bit to talk about the motivations. And really, to me, this is the core of the talk, is talking about how this is evolving, how teams are adapting as they mature, the path that they typically take. So it's an old slide, so I'm getting my brain back into what I was practiced for with the new slide. What we typically have to start, like when we install Rancher for the first time, let's say we've already done our Kubernetes and experimentation and jumping ahead to that point, right? We've decided we're going to use Terraform. And we're going to use Terraform to allocate the infrastructure. We're going to install Rancher. And then we're going to install all the other tools and things that we need on that platform. This is actually the wrong. No, it's okay. We'll just go with it. So we've got this big, massive Terraform that's going to take about 10 minutes to run, and it's going to stand up our management platform, and we're going to be good to go, right? And then we use Rancher to create a downstream application cluster or platform tools cluster or XYZ, whatever you name it, cluster. And then we provide access to those end users to go in and access that downstream cluster or the mini clusters that they have. Then it's up to the app teams. We say, hey, we gave you guys Kubernetes. You're good to go. Cool, right? So they jump into the cluster and they start installing their apps. They maybe there's a load balancer that's already there. They reuse Nginx or something, but they kind of have to figure all this stuff out. Also, maybe we've given them run scripts. Maybe they use Argo or Argo workflows to get some things done. But this cluster that's downstream is just kind of on its own, right? So let's go to that one. Okay. So one thing that we might start to do is we might transition and actually decide, hey, I want to standardize and centralize some of these tools. I want to make it where I can provide some guardrails and say, certain apps need to be installed in these downstream clusters. And I really, in order to enable that, I want to put configuration into a Git repo. right? GitOps. I want to use GitOps to do this thing. So they adapt. These diagrams look really close, but the key change that happens is what we've done is we've said, hey, we're going to use Fleet, and we're going to roll out some manifests to the cluster, which is going to add some connections to some Git repositories that have some app manifests or some Helm, and I'm going to roll those tools out into the repository. Right? So now I've got some common tools, but I still have the same problem where each individual cluster is kind of managed on its own, but at least it's an advancement. And that's typically the first revision that we go to once we start to do infrastructure as code and implement GitOps. Now, the next revision that's really exciting that we're seeing a lot of people doing, there we go, is, has anyone heard the concept of a rep wrap? Kind of dog fooding, maybe, yeah. Yeah, exactly. So rep wrap, the idea is, can we make a 3D printer that makes other 3D printers, right? And can we slim it down as much as possible where you basically can make it from nothing and over time build a better 3D printer and a better 3D printer and a better 3D printer, right? We're seeing a lot of interest in doing that with platforms now, and it's a standard evolution, I think, that we're starting to see. So what happens is that we've already moved and introduced some GitOps to the applications developers, and so they're using GitOps to deploy some of their apps in the downstream clusters, right? But we've actually maybe we say, my Terraform is too big. I don't want to wait 15, 20 minutes for all of these resources to come up. And sometimes, oh man, Cert Manager failed to install, so the whole thing's kaput, right? I don't want to do all that stuff. So let's slim it down as much as possible, and let's just create our compute, and let's throw Fleet or Argo in there, and then use that to point to a Git repo with all the tools and things I want to deploy in the cluster. So not only are we doing that in the downstream cluster, we do that in the management cluster as well. And then after that, right, we can take another evolution. So we've done the same thing for ourselves as providers that we did for the app developers, and we move out. So, and this is the way we do it as well, is we use Fleet or Argo, and thank goodness for you guys at SUSE with Cluster API and all the good things that are coming. But we use that to roll out the tools that are in cluster. We actually use Argo to replace Argo, which is really fun. So it kind of replaces itself. It's like that rep wrap. And then it rolls out standard tooling and definitions there. But we want to take it a step further. So Fleet, want to acknowledge that. A great question in the last talk. Who here is using Fleet or Argo? Both. You are using both. Cool. And, yeah, who is using both? Sweet, very small. Those that aren't using both, why? It's not going to. Yeah, because Argo can do everything. That's a good one.
No experience.
No experience with Fleet or with Argo?
A little bit with Argo, not
Yeah.
so much with Fleet.
Yeah. So it's interesting because Fleet, I feel like, is a more simplistic tool, right? It's more operator friendly. To me, it's easier from a user experience standpoint for an operator to manage Helm charts and identify clusters and manage the downstream clusters for that and keep it like Helm charts. What the pattern that we've started to follow is for COTS applications or for simplified Helm charts or just in general cluster tools, we'll use Fleet for that to help standardize our tool sets across the clusters and let the devs have their Argo. Right? Argo is great. It's amazing. But if it's somebody else's app, I do not want to deal with that diff and re-render. It has bit us in the butt before. It's getting better and it's awesome, but I still think there's a very strong place for Fleet. And that's one of the reasons why I have both in here, is because we're using Fleet for the tools, and we'll use Argo as a utility that we can even roll out Argo individually to other clusters as well. So we'll look at that here in a sec. So next evolution, right? So the next evolution that we see is not only, so in this other, we're still creating clusters from Rancher and doing some downstream things, but the next evolution is we start to move our downstream cluster definitions into Git repositories, right? And roll them out, and just like the rep wrap. I don't want to just create only my one cluster. I want to roll out and functionally think about all of this infrastructure together, right? So I like showing this diagram because If we think about, I'm going to walk in front. If we think about, we've created all these different, we need to create all these different clusters. We talk about the diverse needs of different teams, right? And I think we fall into the trap of trying to say that every single cluster needs to look the same. Every development team needs to use the same tools, right? We can over-standardize a little bit. What we can do by creating separate Git repositories for the clusters themselves and by leveraging the tools in Argo and Fleet to be able to recognize multiple Git repositories by naming conventions and not have to configure everything manually, right? We can enable different provider management teams, we can enable different development teams and give them the capability and flexibility of having some downstream cluster management and tooling management as well. So they can go to their individual repository, the environment that we've created for them, and add an additional tool, deploy an app, kind of manage that on their own. But that introduces some new problems, and it kind of changes the problems a little bit. But by following the rep wrap and kind of the dog fooding pattern, there's also, if we roll out, let me go back to the other slide. If we roll out into these downstream repositories, these managed repositories, Argo workflows, right? That creates with Cluster API, and if you really want to run Terraform in a container, use it as a job, do whatever. That creates the capability of creating those downstream clusters, right? So we can even start to begin approaching the idea of having more of a hub and spoke pattern where we have maybe a central platform team that's enabling another platform team or another ops team that needs scoped access to their downstream clusters. And this is where I need to make sure my slide is in order. Was the text showing up on those? Did I totally miss that? Cool. All right, so second revision, that's where we see people call that the thinnest viable platform when they start to reduce the footprint of their initial deployment as far as possible. This is configuration, individualized, flexibility, but with oversight. When we're in a pattern like this, if we manage centralized repositories for other tools, we can also decide to deploy a subset of standard tools across these clusters as well. So we can maintain some control and some flexibility. Anyone using Kyverno? Kubewarden? Cool. So this idea is great because, right, we can roll those out as some of these extra guardrails and controls as policies. If you use, like Kyverno is used a lot. We're comparing this a little bit to Backstack, and I don't have that. That's Backstage, Argo, Crossplane, Kyverno. We can do things like say, you're not going to allow a deployment unless it contains a CPU and RAM resource definition. You can create all kinds of rules to prevent developers from breaking themselves, basically. But we can roll out all of those policies across all these clusters and standardize those. That's a little bit where New Vector piece comes in for us as well. So what we've done by going through this workflow, we've drastically reduced our Terraform footprint, which is great. It's amazing. It's so nice to be able to do that. We have clusters and cluster tools declared in Git. We also have standardized now, and because we're managing repositories that have collections of standardized tools that can roll out and we leverage Fleet for that, roll those out across across clusters that we can match with. Clusters can now also have independent tools, so we can still provide the access to the downstream users, give them the cluster roles and all the goodness. But we can also now maintain a more hub and spoke, which gives us some flexibility. So one thing that we need to do as we start to make these evolutions and we start to harden what our platform looks like, is we have to go through and we have to identify team needs. We need to start thinking with a product mindset as we are giving these groups these tools to do their jobs, right? How can I not respond to that damn overnight ticket? If that's a problem for you, if you want to stay up, then cool. So we need to identify the different team needs. We need to know what languages they're using or want to use. We need to know what frameworks. Do they have different IDE requirements? Do we have different business requirements? What does their implementation, their home need to look like? Through that, we need to develop golden paths. So we do need to make a choice. there's only so much flexibility that you can allow and effectively have an operational effective organization, right? If you as a platform team are allowing every damn tool under the sun to be run and you're taking over ownership of that, then you will be lost. Like you'll be an inch wide or a mile wide, an inch deep, I guess is the proverb there, right? You fail to get anything done. You constantly have to learn new tools. You get in arguments with coworkers. It's just a terrible situation to be in. So as you go through this and you hit some of those roadblocks, start to develop some of those golden paths. Also, introduce a catalog of paths as well. So don't just talk about the tools that you can use. Let's document the collections of tools as patterns and treat those like something physical that you can purchase, right? This is the way you do web apps. This is the way you deploy a cluster and secure it, right? We can develop those golden paths. One great excuse project, I love the term excuse project because we need an initiative that can help teams focus in their own ways on a project and move something forward, is introducing Backstage. So Backstage is a core of this Barn stack, and I guess I should have said that. Barn is Backstage, Argo, Rancher, and NewVector. It's a little tongue-in-cheek. There's other tools in there too, guys, right? But Barn is fun because cattle and Rancher and all that stuff. Anyway. Is anyone using Backstage yet? Nobody. Who's aware of Backstage? Backstage is hard. It sucks. But it can be really awesome at the same time. So Backstage is essentially, it's a code-first application portal, a code-first application developer portal. What that means is you can't just configure the app in its current state today, and Spotify is working on that. Spotify came out with Backstage. They have a product called Portal. You can look up and sign up for the beta. But there are collections of plugins, user interfaces, that what you essentially do is use Create React App. If anyone's familiar with that from the app dev side, they have their equivalent CLI. You create a Backstage app, and you say, I need a Kubernetes plugin, I need an Argo plugin, I need all these different tools because my developers are accessing these tools, so I need to add these plugins to Backstage. And the workflow with Backstage is a developer will log into Backstage and have a catalog that you'll provide of different applications, different APIs, and now we're seeing different clusters, right? So really interesting that we're doing that, but if you leverage Backstage in an implementation, you have to create a catalog. And so it's a great excuse to start creating that catalog and documenting and defining what your tools look like. So that's a great one. And then we need to look at providing those guardrails. So decide what your Kubernetes management requirements are and start to develop policies and deploy those. And the big one for us on the security side is standardized requirements for NewVector policies. So is anyone using NewVector CRDs or the security policies today? Cool, very cool. Everyone else, it's amazing. You just have to, or give it a try. So the idea is if you're in Helm or if you're in an app workflow and you're rolling out manifests, right? When you install NewVector, it's going to do its best to discover all the different security all the different network rules, the file access rules, and things like that. Once it discovers those, you switch over into a different mode, which is monitoring mode or discover mode, so you can warn on the app or lock down the app. But you've spent some time developing these rules. You can just export those as Kubernetes resources. So allow your security teams to export those Kubernetes resources and then just provide them back to the dev teams and include them in the Helm charts, right? And so at that rate, when you update your app the next time, it's going to roll out with the security policies. So if you built your CI/CD flow, you have your dev stage prod, you can export your policies, include them in dev, move them into prod or into stage or prod when you're ready, have those roll out. Really, really, really nice. But the key thing we're doing there is we're creating overlap amongst teams. All right. So we've got some scatter here. Yeah, let's jump to that one. The other side of this that I want to talk about, this is near and dear to my heart. And it won't let me zoom. Can you guys see the text okay on this? Ish, okay. Yeah, I'll try that. That's a good point. I just can't, you can't get all of it that way. We can pan around. All right, and there's some extra notes in here, I know, but it's okay because a lot of this is fluid and moving. What I wanted to look at here, this is really the different layers of things that different users up top need to interact with in order to functionally operate a platform or run their applications in a platform. When we talk about how much developers need to use Kubernetes, there's a lot of power in the ability to have infrastructure as code, to have software-defined infrastructure, right? A lot of power in being able to say, I need a load balancer, and just being able to do that by creating an ingress, right? If developers reach that level of maturity where they can think about Kubernetes as their interface to have that infrastructure, the infrastructure they need, it can be a really, really, really powerful tool. But it can also be a huge burden, right? It's a lot of complexity, and not everybody needs that level of access. But what I'm trying to show in this diagram a little bit, and it's not all-encompassing, is just the tools that they need to use to access and manage different portions of the infrastructure. So up at the top, this is chaotic. Right now, developers, if they need to get in there, and it's a good reason why we have Argo CD up there, now we're saying you need to use GitHub, you need to use Backstage, you need to use Argo, you need to use NewVector, you need to use Rancher, you need to use your monitoring tool. Like, you're adding and adding and adding all of these tools. And the biggest challenge today is that all of those damn tools have their own interfaces. And if I want to go explore why a service isn't operating properly, I may discover that by seeing something failed to sync in Argo, and I need to come all the way back up from my context black hole and go over to Rancher and go all the way back down in the services, right? And then come all the way, fix something, and then call all the way back up and go back all the way down into Argo. We have this like vertical chain that we constantly have to follow. And as a developer, it sucks. It's the worst thing. And then now we're saying you need to use Backstage also, and then you need to go take these policies and put them in GitHub. It's a huge pain. And on the, like, NewVector is great too. But it's the same thing. Now you're asking a dev to go figure out why his file access rule isn't working properly because you said you can't have root access and, you know, all the other things that they're supposed to be doing. But if we go to, oh, there we go. So we have some notes here. All right, so I don't know if this is true. I call that vertical context switching or vertical switching versus horizontal switching. To me, horizontal switching means that I can easily move from left to right between my different tools and stay in the zone, like know exactly what I'm working on. I don't have to think about the switch. The vertical switching, we call, you know, it's like rabbit holes. I have to know the tool, and I have to think about how to use the tool to get to the information that I need. All we need to do to try to encourage horizontal switching is encourage that tooling overlap, the interoperability, to be able to move from one thing to another, right? So reduce the distance between those capabilities, and we want to focus on the capabilities, right? If the capability is provide an ingress, I need a way for people to access my app, let's make it as easy as possible for the users of the different types. Like, I want to be able to go from the service in Argo and jump straight to the service in Backstage or jump straight to the service in Rancher. And with Backstage, you can do that-ish right now. You can view the service just like you can in Argo. So Argo, you can view the service as well. All three are interdependent. But with Backstage, we can at least say, hey, I want to add this little UI, this little link that uses a cluster prefix for this workload and takes the cluster ID, and I want to jump over into the Rancher UI. So we can do that with Backstage. Now, the key, though, is also Rancher. Can we do that with Rancher? So this is where some of the, I don't know, maybe it's a little controversial, and maybe I should get back into this thing. Let's zoom in here. So we had chaos before. Promise this comes full circle. But we had chaos before with all of the different apps that we needed to use. And it's great because we had direct access to all those things, and we can dive in deep when we need to dive in deep and take full access or full use of the tool. Now, with extensions in Rancher, who's aware of extensions? All right. Hell yeah, extensions team. love extensions because just like Backstage, and if Backstage is saying, hey, it's okay, and the industry is saying Backstage is awesome, we all need to adopt it, it's a pretty good indicator that it's okay to have a code-first approach or to be able to build these additional interfaces. Has anyone heard of progressive enhancement? If anyone was in the other talk, I did this too. Progressive enhancement is terminology, or it's a methodology that comes out of web application development. Probably 8-9 years ago, we call the Great Browser Wars were happening at the same time as the Great Container Wars, right? The Great Browser Wars was Safari, Chrome, IE/Edge, all these different, Firefox, Brave, whoever, all these different browsers were competing for footprint. But they were all trying to introduce new features the fastest. So like, hey, I want Bluetooth capability. Hey, I want to be able to select different speakers. Hey, I want to remember which speaker selection I did. There's all these different new proposals that people were submitting to the W3C. But the challenge was that if one browser implemented it and you wrote code for that browser, it would break when you went to another browser. But there was an idea that if we approach development with the idea that if somebody wants to take advantage of these capabilities, they can. So we'll detect and layer on additional capability if it's available to the user. Like, hey, their phone has Bluetooth, let's allow them to connect, right? Or at least show them a screen that says something won't work. That ability to progressively enhance the experience of the user. Service workers was a big thing with PWAs. If the browser has capability of service worker, which is like a local server, like moving some data and logic and caching and stuff to the client device with definitions. If that exists, take advantage of that, but opt into it, but still don't break the functionality of my app. I look at Rancher and the SUSE ecosystem from that approach anyway, and extensions I feel like is a great attack or an answer at that. So with an extension, I can use logic, and a lot of the apps use this already. Apinio has some. If I detect that there is a capability available in the cluster, I can augment my user experience based on that. So in extensions, we can build some logic, and we're doing that, but you can build some logic to say, hey, if new vector exists in this cluster, show new vector, right? Hey, if Argo exists in this cluster, let's show the application definitions, and maybe we can show those alongside the Helm definitions, right? We can layer in these extra experiences. But the great thing there is we can also do things like introduce a link, or maybe an example would be cube cost. If you make an API call, you can layer in the cost of your cluster into the cluster management table, right? Or just put it in the card. But if I see that and it says $10,000 last month, I'm going to click on that, right? And if it can take me where I need to go in cube cost, that's awesome. And the beauty of that is now I don't need to build a complicated cost management interface that's going to live in Rancher, and Rancher becomes this big behemoth. It takes me to the right place, right? And if I have another cost management tool and I want it to be included, let's do an extension, bro, right? Let's move that in. So, and then maybe we can abstract our extensions and say my extension can handle multiple different cost management tools and augment the experience for that. So a bit of a shill for extensions there. Really excited about that, how that's moving. Please convert the UI to web components, please, Neil. All right, let's see. Time check. We're at 6:06. Anyone know when the first bus leaves? Is it 6:15? 6:30? Okay, cool. Okay, sweet. Thank you. All right. Do I want to show this stuff? All right, we're going to get a little more discussion-based since the other slides were all broken, and I got as far as I could down here to get that. I don't want to talk about that yet. Okay, so as we rethink the platform a little bit, I still think there's a big challenge where infrastructure teams are tasked with doing all the Kubernetes management and making tooling and system decisions that aren't beneficial to the developers, or the developers try to demand and use tools and refuse to use things provided by the infrastructure teams. That's okay. We're going to talk about that a little bit. But challenges for developers with the platforms today is the context switching and retooling is probably the biggest challenge. If I need to move from project to project, I may have to use a different IDE, I have to use different observability tools, I have to use a different method of storage, and if I'm at a large enough organization, step back for a second, there's a really, really big problem in the industry where we talk about stuff like it's easy, right? It's like, yeah, sure, we're gonna have a platform and it's gonna work and it's gonna be great. Yeah, just throw some AI at it, that's gonna be awesome. We all know it doesn't work like that. It's a bunch of icebergs everywhere. There's a ton of implementation that takes rubber meets the road. So at a large organization, we're not going to be able to operate at scale with one platform. We're not going to be able to operate and have one IDE to rule them all. We're not going to be able to have one code base, like one framework, one particular language we use. We can't hire people that way, right? We have to take advantage of their skill sets and the way they can fundamentally process and develop software, not limit them to the specific one language that they have to use. We need to be able to provide them with better tools, but we can go too far there, right? There can be too much flexibility in every different project. Then a developer is going to take 2 hours to switch between projects. They have to do 4 different features across 4 projects in one day. That means they got a good 5 minutes on each project that they needed to work on, right? So that's where lack of choice can be good or bad. The responsibility model clarity. Does anybody have a responsibility model that they've put into place in their organization? A little bit. It's a start, like social contract, right? You guys are going to be responsible for this. We're going to be responsible for this. It's a great start to do that. Create that social contract that says that, and you'll understand how to design your environment. Let's see. And then probably the other biggest one that we're all aware of is environmental parity. So a big challenge is I may deploy this on my machine and it won't work on the QA guy's machine and it won't work in production, but it does work in stage, but it might not work in dev. We need to find ways to have parity in these environments, but we also need to find ways to give developers access to the desired environment where this thing needs to run so that they can test in production effectively, right? Does anybody have a situation where their developers cannot touch production? I know there's one of you. Yeah, that's a challenge. That sucks, right? Like as far as I'm going to release something and it has to go get committed into production and the QA team is going to try to review that before maybe it comes back and there's been 10, 20, 30 pull requests or new features that have been added and I don't know if it was mine that caused the break, but everybody's panicking and there's a fire alarm. That's crazy. Like try to give me an environment that's as close to production as possible. But that's a big challenge too. And where the evolution, this is where I go back to another one of the slides, but there's an evolution that needs to happen there, so we'll do that. Now, but I want to acknowledge on the other side, the provider challenge. This whole thing is to talk about why stacks are important. The support diversity that comes into place, right? Like developers have all these different tools, the systems teams have all these different tools, there's all these different groups you have to work with, but you're being tasked to like maintain this thing or make things work. You could have hundreds of tools that suddenly need to get managed. And if you don't provide some negotiation or rules in place or say, no, I'm not gonna touch that thing, that's probably the biggest thing you can do is say, no, that's not gonna be supported. But you're gonna put yourself down the wrong road. But that support burden is unintentional because as the organizations gain in maturity and you form a platform team, it starts to sound like it can be this end-all be-all catch-all. And that's the reason why I wanted to talk about it's okay to have multiple platforms. Because if you still have a highly independent development team that is maintaining their own infrastructure and doing their own thing, maybe they should just stay that way for a little while. You shouldn't try to do everything at once and just adopt everything. Another big challenge that we see on the provider side is this lack of a product mindset. So we're not thinking about the things that developers are actually doing and the way that they're, like the business value, the apps they're trying to build, what problems they're trying to solve, and what capabilities help them get there. We just feed them things and make them use it. We need to be working with the developers, with the consumers of the platform, and allowing them to give us feature requests tell us when things are broken, right? We need to serve, like we're operating a SaaS product at that point. We need to have that interaction and exchange where we can iterate and they can do pull request, or we can do our own pull requests against the platform, but they can do feature requests and everything else. But it's really, really difficult to iterate on the platform today because people will put one operational platform in place, but they haven't built it to be composable, repeatable, like tear it down, spin up a new one, do all that. Let's see. So I wanted to talk about that. Yes. All right. So incomplete slide, but I'll use it. The concept of a software factory is core to what we do. So at Crumb, we grew into this platform engineering world from the application developer side. We were developing cloud-native applications for folks, especially those who didn't have Kubernetes or virtualization or any sort of management capabilities. Maybe they were on IIS or something like that. And we found out early on that we needed to build competency and expertise in giving them the tools that they needed so that we could do our jobs, right, as a part of that journey. And that's why we adopted Rancher back in the day, is we used it as a training tool for Kubernetes for infrastructure teams as well as developers. It gave us an interface that was close enough to infrastructure management. This is how we use NewVector 2 today. But it gave us an interface that was close enough that you could go click, add a deployment, check the YAML, say, oh, that was cool, the image changed. If I want to change the version, change it here. What if I change the YAML, right? We're kind of meeting them a little bit in the middle and building those bridges. But we look at this overall platform concept as a software factory from that point. If you think about manufacturing, right, these big factories or BMW or whoever, you have lots of different people that have their specific roles. There's lots of effort that goes into optimizing certain paths or certain parts of the assembly line for different users, right? We do a lot of work to find augmented reality and creative ways to train operators so that they can get up and rolling quickly. There's lots and lots of similarities in the factory, just straight up manufacturing concepts that we're not necessarily adopting or applying in the software world. We think we have to reinvent everything. And so I really like talking about that concept of a software factory. But you have to define those processes. And what we're looking at as Stacks is maybe this concept of having a factory of factories, right? It's just like the rep wrap. It's the ability to print these platforms and allow these platforms to have all of the tools encapsulated that a developer needs at any given time, right? So maybe a developer needs Argo, maybe they need Fleet. I don't know. It doesn't mean that needs to go into one central cluster. What if we can make our individual clusters composable and have those tools that they need at the right time? And that's where we're using Barnstack. But then my diagram is gone. So I'm going to go back up to this one. All right. All right. So I'm going to use this one with DevStage prod, right? So if we want our developers to follow a certain pattern and use certain tools, we need to be able to centrally manage and put guardrails and maintain some of those central tools. We do that by living in this type of architecture, right? By using the Git repos, and if we need to create a new developer environment, we can define that developer environment in code, and we can do a pull request against our primary tooling, our cluster repo, and have that add the manifest, which roll out, trigger and roll out a downstream cluster. That cluster will reach back out to an interface with our app manifest, and then automatically roll out the tools in that cluster. How that works today is manual creation of GitHub repos. But how it will work tomorrow, and I wish I had a demo ready for you, but we'll pull our hair out. Backstage, right? Backstage gives us a concept called generators. We can use Backstage to create Kubernetes manifests and create repositories and roll out and populate those repositories. It can even generate pull requests. There's a lot of functionality there. So the workflow becomes, I've got a catalog of different developer environments and application types, or let's focus on the applications types. I need to develop a new enterprise web application. And I need developer environments and DevStage prod for all of that. Now we can actually predefine those in templates in those generators and roll those out. So a developer can create their own development environment, and we use Coder, and or we have some flexibility on IDE. If anyone's using Daytona successfully, please let me know, because I'd love to chat about that. I spent a lot of time on it and didn't get it working. But inside of each cluster, we can tailor that cluster to the needs of that particular development team and kind of build those tools. So if they say, hey, we need VS Code, let's give them VS Code. Let's use something like Coder, right? Hey, I just need a vanilla Kubernetes cluster. Cool, we can define that. But we need our centralized tooling, and we need to standardize. So our Barn stack is that centralized tooling. It's that standard collection of tools that rolls out across every cluster. And where that comes in with NuVector, right, is we may need to have an independent NuVector instance that isn't necessarily a federated NuVector. It might be a little bit more heavyweight, but in our clusters right now, and hopefully we can optimize and shift left a little bit, but right now we just deploy NuVector as a standalone instance inside of every single downstream cluster. And what that affords us to do is, as every app that gets deployed, we have our policies defined that we roll out with Argo in this case, and not Fleet, but we roll out the policies with Kyverno into the clusters themselves to say, I need to enforce existence of, and today it's individual security policy resources inside of the namespace is the best way we can detect it. We're trying to get a little more creative with it. But if you deploy an app or a namespace without a security policy, it won't deploy, right? So really, really cool. But you can start small and just deploy an initial template and go from there. So lots of fun there. But that's where the NuVector comes in for us. So we get security by default because we don't allow anything to get deployed on there without a security definition from NuVector. Let's see. I wish I had the Backstage thing for you. So any questions on that?
Yeah, I would have one.
Yeah.
About the mentioned golden paths,
Mm-hmm.
they're a part of the Backstage, right? Or not really?
So Backstage would be like the manifestation of your golden paths, if that makes sense.
Yeah, kind of. Why I'm asking is, we did just a POC with Backstage, and I'm curious whether
Mhm.
isn't there like extra operational overhead to maintain all these templates and Backstage, because we have
Mhm.
already doing in the platform.
Mm-hmm.
Backstage is for me like another instance with all the problems we need to make.
Yeah, like it's almost like application sets or something too, right? But it actually, I think, is an instance of good traction, or like good friction that creates traction. Because if we force Backstage as like a documentation tool to standardize what that application and its tool sets need to look like creating that catalog entry, I think is a really important part of the definition process. If most times your Backstage journey will be you put Backstage in place and then you use an import tool and kind of bring your applications into it. But when it comes time to like codify that and say, this is the way we're going to do the thing, you can use the catalog generation as a way to harden that and do that. But you're right, there is additional overhead. And one of the things that I would really like to see that is on our list of next extensions to develop, we're developing a collection of extensions that kind of focus on the non-operator developer experience so we can provide that in Rancher. I would really, really, really like to have a way in Rancher to list some of the catalog items as well, or to show on an app or a workload that it originates from Backstage. I can do that today through the labels and annotations, but I'd like a way to just visually be able to do that. Because in Backstage, you can view the Kubernetes resources and see where they are if you catalog it correctly. Because you have to link back to Backstage and say, these are the clusters, and it has a discovery tool and all the nice Kubernetes things. But I would really, really, really like to see that integration inside of Rancher. We use Rancher as a gateway, like a boundary access. If you have access to that cluster, then you have access to the tools in the cluster. And one thing I'm not showing is there's also the complexity. Should you have one or more Backstages also, right? How do you do that? Big organization, but I probably rambled and didn't answer your question, but we'll get back to it.
Yeah, sounds like
Yeah, I think it goes back to like right tool, right user, right time. Like Backstage might make more sense to the application developer who needs to compose their app, and it could be a good way to enforce that. Yeah, sorry, go ahead. Question?
Where can I find those Rancher extensions so you
Yep. So we have one that's public, and we're working through the others. The first extension that we have is called the App Launcher. So talking about the vertical context switching, the horizontal context switching, I think the most classic case of this in Rancher is I deploy a new app, and I have no freaking idea what the ingress is. So instead of just giving me the ingress, I have to go dig down into services and do that. So that's actually, I'll just pull up the repo so you can get the title. But, and I'll show you that extension as well. So, yeah, as a developer, I've made a PR, and that PR has automatically rolled something out, and it's put it somewhere, and I have no freaking idea where it's put, unless maybe my DevOps team has made a comment back to the PR and said, hey, congratulations, your site has been launched, here's the URL, right? But I have to go dig for that. I don't want to dig for that. And what about the QA guy who knows the name of my branch but doesn't have any idea how to use Rancher? But we need to get to that resource. And what about the situation where we don't have an ingress for this application? It's not exposed yet. Well, how am I going to communicate to QA guy? Just launch the proxy. Or port forward. Yeah, just port forward. I hate that. I hate seeing that on repos. Give me another way. So we always direct people through the Rancher proxy. So this is a sandbox account here. We got a lot of clusters here. My backpack is here, but with Harvester, but it can't register because we're not connected to the internet. We got a lot of good experimental stuff in here. So I've deployed an app. How the hell am I going to know where this is? I have no freaking idea. I know what the app is called, but I don't know what cluster it's on. I can't use search. And so all we've done, simple extension, we've reused some of the UI assets. We just built an Okta-style app launcher, right? So we're reusing the existing card, and we're showing it's the same methodology for if we have multiple ingresses, right? It feels a lot like Argo too. I think it's just coincidence. But we have a ton of different things in here. But I just want to find one of my PRs, right? So here I've got a PR, and I just want to launch that URL. So now if I'm a QA person, I just go to the app launcher. I don't dig into the cluster at all, right? So that's really cool. But it just abstracts just enough of the information away. If I'm an operator and I want to have a collection of tools that I want the developers to use, but they don't show up in Rancher because it was deployed via Argo and not in an apps list, then I can just add an annotation, and it gets tagged and added to this global collection up top. So then I'm able to centrally manage that now by just updating the objects, right? The Kubernetes objects, or updating it in my Helm chart, promoting it basically to be global. So just one simple little thing there has made it so much easier for non-operator users to get in there and use that stuff. But that's why I'm excited about the new vector extension as well. We've deployed it on ours, and it's just, is it GA now, the new vector extension, I think? Okay, awesome. So, yeah. Yes. Yeah, we're just going to publish these. So that's crum.io/crum rancher extensions. All right, can we zoom on the... I should have a QR code, huh? Who would have thought? So github.com/krumio. Crum was taken. We got it later, don't worry. /crum-rancher-extensions. And this is where we're going to be publishing most, if not all, of these platform extensions. Some of them are just not public yet. But we're trying to use the extensions. They go back to the barn stack stuff, right? It's one thing to have a stack and deploy, just have Argo on there, have Backstage on there, have whatever. We need to tie them all together. And if I go back to the slides, yeah, we got to make the bus, don't we? Where is I pulled that from the thing. I want to go back to this one. So if we go back to our entry points, instead of having all the chaos of going to each individual tool to do the individual thing. If we use an extension to facilitate, hey, just get me in Rancher, that gets me close enough to the resources, gives me the access, the secure access, use it as a boundary access tool if you have to, even if it's not intentional for that, but we love to use it for that. If we had a way, I'm just doing feature requests because Neil's in the room, but if we had an OIDC provider that we could use to authenticate our app against the Rancher proxy, it would be brilliant. Like super awesome. But if we can get the users in Rancher and control access to the apps like we do the infrastructure, it would be invaluable. It would be awesome. And then we would also, from a business side, we would increase the amount of users that are in Rancher, which would further the adoption of Rancher at an organization, which would result in more nodes and more things deployed and managed by these things. So it actually can encourage an adoption cycle as well. But those extensions will be able to take us back and forth. And is anyone working on a Backstage extension? Because I don't want to like redevelop stuff that the SUSE team is already working on, because that would be cool. Anyway, awesome. So I think we're out of time, but questions, anybody on this stuff? Sorry, I'm not showing you a barn stack demo, but cool. Bus time, party time. Everyone's enjoying SUSECon? Cool. All right, thank you guys.